Hey guys, today we are talking about complex numbers and complex equations. This is lecture 1.3. All right, so we have talked about how to solve linear equations. With linear equations, the x is raised to a single power. Yeah, such as 2x or 2x plus 1. It will have one solution or less. Or no. Saying no solution. Okay, or we have also talked about quadratic in unit 1. Quadratic, x will be to the second power. So you would have maybe 2x squared plus x plus 1, right? Here you could have two solutions, one or no solutions. We also talked about solving quadratic equations using the quadratic formula, finding the solutions using the quadratic formula. And we had to stop the quadratic formula process if we got a negative number under the square root sign, right? We have to stop, we have to say there's no solution to the problem. Today, we are talking about the imaginary unit I. So when you see the letter I, it means the imaginary unit. And it is a way to solve a problem with a negative number under the radical or under the square root sign. Okay? It's called the imaginary part. Sorry, it's called the imaginary unit I. Okay? So it's a bit like how in algebra, if we have a problem with an unknown number and the unknown number kind of stops us, we can represent the unknown number with a variable such as x, right? So if I was saying 2 times a number, I can say 2x, right? I represented the part I was describing with words with one variable. So now my problem is I have a negative number under the exponent. So instead of a variable, I'm going to use the letter I, but you can treat I like a variable, okay? So the presence of a negative number under a radical stops us. The imaginary unit allows us to continue working until the problem is solved. Here is what you need to know when working with complex numbers. I is equal to the square root of -1. So I squared is equal to -1, okay? The imaginary unit grouped with a real number is called the complex numbers or the complex number system. The complex numbers a plus bi, okay? A is the real number. The real part means you can find it on the number line. It is a number on the number line. And then bi will be the imaginary part of the complex number system. Okay, we can do things with complex numbers such as add them, subtract them, multiply them, divide them, graph them. Okay, today we are going to practice combining them, and then we will apply them to the quadratic formula. So remember last class, there was a problem with the quadratic formula and we left it as no solution because we have a negative number under the radical. After today, you will be able to solve that problem. Okay, we will be able to continue with problems with which we thought we had to stop because of a negative under the radical. So here, example 1, 4 plus 6i plus -1 plus 2i. We're always looking out for parentheses, right? What are these parentheses doing? What are parentheses usually doing? Usually parentheses are just telling us to combine if the terms are alike, or to distribute something through the parentheses. But if you look at this one, you cannot do either. You cannot combine 4 plus 6i, and there's nothing to distribute in front of that parentheses, or behind it, really. Okay, so you can treat I like a variable when combining complex numbers, okay? So that means you can put 2i with the 6i, you can't put 2i with the -1, okay? So here, we're actually just combining like terms. All the parentheses is doing is separating two complex numbers. There's nothing to combine inside, nothing to distribute outside. Combine the real parts, 4 and -1, and then combine the imaginary parts, 6i, 2i, okay? All right, so this is a positive, so we don't need to distribute anything. 4 minus 1, 6 plus 2i. So all I did is I moved this below this one. 4 minus 1 is 3. 6 plus 2 is 8. 3 plus 8i. I kept the real ones with the real ones, imaginary ones with imaginary ones, and I'm finished. The solution to this is 3 plus 8i. I combined like terms, okay? With our second part of example 1, we do need to distribute something. Do you see how there's a negative sign? So because there's a negative sign, I'm going to distribute it before I do anything else. So now I have 4 plus 6i plus 1 minus 2i. A negative times a negative is a positive. A negative times a positive is a negative. Or you can rewrite it 4 plus 6i and just put the other one right on top. 1 minus 2i. 4 plus 1 is 5. 6 minus 2 is 4. Okay? You have now combined complex numbers. Let's multiply complex numbers. All right, it's also important, leave it in ABI form, okay? Standard form. A plus BI, okay? So you always want your answer to be an A plus BI form. And it's okay if, like here, you don't have an A, but if you do, make sure they're in the right order, okay? Real number in front, imaginary number in the back. Okay, what are the rules for variables when multiplying? Do you remember the rule for variables when multiplying, or sorry, rules for exponents when multiplying? Okay, we keep the base and we add the exponents. So xm times xn, the way we solve it is x, we leave x the same, leave the variable the same. We add m and n. Or you could say 5 to the third times 5 to the fourth equals 5 to the third plus the fourth. Okay, so I squared, what did we learn about I squared? I squared is -1. So we're going to use the same rule. So this would say x times x becomes x squared because it's actually 1 plus 1 becomes 2, right? So I times, sorry, I said plus x. I times I becomes I squared, but what we know about I squared is that I squared becomes -1. So keep going. Anytime you have an I squared, you can change it to a -1. You can replace it with a -1, okay? So let's try this one. 2i times 2i. 2 times 2 is 4. I times I is I squared. So 2i times 2i becomes 4i squared. I squared becomes -1. Take out the I squared, put in the -1. 4 times -1 is -4. You are done. Okay? Six plus 5i times 3 plus 7i. I hope you're thinking this is a binomial. These are two binomials. 1, 2, 1, 2 binomials. I need to distribute or I need to FOIL. Were you thinking that? Good job. All right, so first, 6 times 3 is 18. Outside, 6 times 7i is a positive 42i. Inside, positive 5i times positive 3, positive 15i. Last, 5i times 7i, 5 times 7 is a positive 35. I times I is I squared. So we just FOILed the two binomials because we were multiplying them. Now let's simplify. 18 plus 42 plus 51, sorry, 42 plus 15 is 57. What can I do to I squared? I can turn it to a -1. Minus 35, because 35 times a -1 is -35. 18 minus 35 is -17. So my final answer is -17 plus 57i. Real number in front, imaginary number in the back. Okay. Last one for example 2. 3i distributed through -2 and positive 5i. Okay. 3 times -2 is a -6. There was only one I, -6i. 3 times a positive 5 is 15. But now we have two i's. Negative 6i plus 15i squared. Negative 6i plus 15i squared becomes a negative 1. Negative 6i minus 15. Now I'm just going to flip them because I want the real number first, the imaginary number second. Yes, look at us fly through this. All right, so we used this rule to change some of the imaginary numbers to real numbers. We have added, we have subtracted, we have multiplied. We have treated I like a variable. We have followed the rules of exponents. We have replaced I squared with -1 anytime that we could. And we practiced distributing and foiling. Okay, great job. Example 3. Oh, we're going to skip. Okay. Complex conjugates. First, I want to do 2 examples from example 4, and then we'll go back to example 3. Okay, so go on to the next page. For example 4. Oh, remove I from the denominator. Okay, so remember that you can't leave a radical in the denominator of a fraction. It is considered improper, right? So anytime we had 5 over the square root of 2, right? We would multiply the top and the bottom by the square root of 2. To get rid of the square root, right? It's okay if it's in the numerator. It's not okay if it's in the denominator. The same is true for imaginary numbers, because an imaginary number is just this in camouflage, okay? So remove I from the denominator to make the fraction proper. So we have 3 plus 2i. We have 3 plus 2i all over I. We need to remove the I from the denominator. It's also known as rationalizing the denominator, making the whole fraction proper. We're just going to multiply. Here, we just multiplied them both by the square root of 2. Here, multiply the numerator and the denominator by I. I'm going to put it down here because I'm going to run out of space. Number 1, 3 plus 2i over I. And I'm multiplying by I in the numerator, multiplying by I in the denominator. Because I want this gone, and anything I do to the numerator, I have to do to the denominator. I times I is I squared. 3 times I is 3i, so I'm distributing this through. Right? Plus 2i squared. I see some I squareds. Let's turn them into -1s. 3i plus 2 times -1 all over -1. Okay. Now, that's 3i minus 2 over -1. Because of the minus sign, there are 2 fractions now, okay? There's 3i over -1, and there is -2 over -1. So 3i divided by -1. Anything divided by a -1 just changes the sign, right? So now it's just -3i. -2 divided by -1 is a +2, right? So I divided both of them by -1 independently. And remember, I want the real number in front, the imaginary number in the back. So I'm just going to put the 2 in front of the -3i, and I'm done. So the answer to number 1 is 2 minus 3i. Number 2. Number 2 is 2 minus 5i over 3i. Do I need to multiply it by 3i or just by I? There's nothing wrong with the 3. The only problem is I can't have an I. So I'm only going to multiply it by I. Okay? I is the only part I need out of the denominator. The 3 can stay. So again, we have to distribute on the top. 2 times I is 2i. -5 times -5i times I is -5i squared over 3i squared. 2i minus 5, the I squared becomes a -1 over 3i squared becomes a -1 here too. I'm going to flip them, okay? So -5 times -1 is a +5, right? Plus 2i. So I just wanted the 5 because now it's the real part of the equation. I want it in the front. So I took the -5 times a -1, got a +5, moved it in front of the 2i. 3 times -1 is -3. Okay. We can look again. Can I simplify this? Does 5 go into, or sorry, does -3 go into 5? No. Does -3 go into 2i? No. So it cannot be simplified. So we can just leave it as 5 plus 2i over 3. Sorry, -3. Which I guess you could change to -5 minus 2i over 3. You could put the negative sign out in front and put these in parentheses, or you could leave the negative sign with the 3. Anyway, that does not matter. All right, so we wanted to do 2 from example 4 before going back to complex conjugates, because that one was just one imaginary number, but here is a complex number with the real number and the imaginary unit in the same, both in the denominator. So now we need to know how to remove a whole complex number from the denominator. Okay. A conjugate. Okay. A conjugate is the same binomial with the opposite sign between the two terms. So a binomial has two different terms, binomial. The conjugate of a binomial is just the same binomial, but we change the sign between the first and second term. You could also say you change the sign of the second term. So a plus bi is a complex number. Its conjugate is a minus bi. That is all. Okay. The product means multiply, right? The product of a complex number and its conjugate is always a real number. So the reason we need a conjugate is to get a real number. Find the product of the complex number 2 plus 5i and its conjugate. Let's make up an example. Okay, first, let's say 3 plus 2i. Yeah? What is the conjugate? Its conjugate is the same numbers, but we change the second sign, or we change the sign between the two numbers. 3 plus 2i. Its conjugate is 3 minus 2i. Okay? You will find, if you multiply these two, let's just do it. If you multiply these two, the answer will be on the number line. It will be a real number. Okay? So 3 plus 2i, 3 minus 2i. First, 9, right? 3 times 3. Outside, minus 6i. 3 times negative 2i. Inside, 2 times 3, 6i. Last, positive 2i, negative 2i, minus 4i squared. Okay? Negative 6i plus 6i cancel each other out. Now I just have 9 minus 4i squared becomes negative 1. 9 plus 4, because negative times a negative is a positive, that just becomes 13. So by multiplying the imaginary number by its conjugate, I get a real number every time. Okay? So that was just an invented example. This one says find the product of the complex number 2 plus 5i and its conjugate. 2 minus 5i. 2 times 2 is 4. 2 times negative 5i is negative 10i. Positive 5i times 2 is positive 10i. Positive 5i times negative 5i is negative 25i squared. Negative 10i plus 10i becomes 0. 4 minus 25i squared becomes negative 1. 4 plus 25. Sorry, I was looking at the computer screen. Our final answer is 29. Looking at the computer instead of my hand. That sounds hard, right? Complex conjugate. Flip the middle sign, multiply it, get a whole number. So nice. Okay, so we did 1, 2. Let's do number 3. Do you know what to do to rationalize this denominator? You could use a complex conjugate of 1 minus I, right? I'm going to move it down here. 2 plus 3i over 1 minus I. I can't multiply it only by I because of that minus sign. It's a complex number. So I'm going to say all of this multiplied by 1 plus I, the complex conjugate. 1 plus I. Okay? Now we're just doing a lot of foiling. First, 2 times 1 is 2. Inside, no, for outside. 2 times I is 2i, positive. Right? Inside, 3 times 1 is a positive 3i. Last. 3i times I, positive 3i squared. So that was first, outside, inside, last. We're going to do that on the bottom too. 1 times 1 is 1. Outside, 1i, I can just call it I. Inside, negative I times 1 is minus I. Last, negative I times an I, negative I squared. Okay? Foil the top, foil the bottom. Let's see. The like terms are 2i and 3i, right? So we'll leave the 2 the same. 2 plus 3 and 2 is 5i. Plus 3, instead of I squared, I'm going to say negative 1, right? One. Positive I minus I cancel out. Negative I squared. So we just have 1 minus I squared, negative 1. So now I have 2 minus 3, right? Because 3 times a negative 1 is a negative 3. Plus 5i over, what is this? 1 minus negative 1 is 2, right? Two minus 3 is negative 1 plus that same 5i over 2. 2 does not go into negative 1. 2 does not go into 5i. So that's my final answer. Negative 1 plus 5i over 2. Okay. How would this help us solve quadratic equations? Remember, what stopped us with the quadratic equations was a negative under the radical for the quadratic formula. So let's use it in the quadratic formula. Let's use it in a radical. So that was 1, 2, 3, negative 1. The square root of, so 4. Just keep going. 4 was the square root of negative 1. The square root of negative 1 is I. Done. Okay. Number 5. The square root of negative 25. That can be the square root of 25 times the square root of negative 1. The square root of negative 1 is I, right? And the square root of 25 is 5. 5i. Done. 6. The square root of negative 12. That can be the square root of 12 times the square root of negative 1. 12 can be 2 and 6, or 2 and 2 and 3, right? Two times 2 times 3 times negative 1, right? So we can change that 12 to 2 times 2 times 3 times negative 1. These can come out and this can come out. Just like up here, the square root of -1 is I. The square root of 2 times 2 is 2, right? The 3 stays there. So we have I, 5I, 2I square root of 3. That is how we can use it for simplifying a negative under the square root. Solve each equation in the complex number system. Your solutions might be imaginary. So all we're doing here is solving for x, okay? X squared equals 16. If I want to get rid of the squared, I just do the opposite. Should I get closer? I always run off the page when I get closer. Whew. All right. Solve for x. Remember, if I add a square root, I need to put a plus and a minus sign. The square root gets rid of the squared, so I just have x is plus or minus the square root of 16. The square root of 16 is 4, right? So x is either a positive or a negative 4. That was all. No negatives. All right, x squared is negative 25. Here's a negative. X squared is negative 25. Just throw a square root and a plus and a minus, okay? I can't take the square root of a negative number, so I break it apart into a square root of 25 and a -1. So x is plus or minus, right? The square root of 25 times the square root of -1. If I rewrite that again, x is plus or minus, the square root of 25 is 5, the square root of -1 is I. So x is plus or minus 5I. You're done. Okay. Oh, solve each equation. X squared minus 2x plus 5 equals 0. So we have a quadratic equation, and we need to solve for x. Okay? Do you see a way to factor it? Do you see a good way to complete the square? No, we might want to just go straight to the square root method, or sorry, the quadratic formula. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is what we're going to use to solve the equation. So for this problem, a is 1, b is -2, c is 5. X is -2 plus or minus the square root of -2 squared minus 4 times 1 times 5 over 2 times 1. negative times a negative 2 becomes a positive 2. You can put all that in your calculator if you want. I think it's just 4 minus 20, right? Over 2. 4 minus 20. Negative 16 over 2. So this is usually when we stop and say no solution, right? But actually, we know that negative 16, sorry, the square root of negative 16 can become, it's not enough room right there. We know that the square root of negative 16 can become the square root of 16 times the square root of negative 1, which becomes 4i. So this I can replace with 4i. Two plus or minus 4i over 2. Two divided by 2, that can just turn into 1, right? 4i divided by 2, that can become 2i. So now I have 2 divided by 2 is 1 plus or minus 2i. And remember, those are two different answers. So your answer could be 1 plus 2i. Your other answer is 1 minus 2i. Those are all the skills you need in order to work with negatives under the radical. Okay? And there was no example 5. We went right from example 4 to example 6. So you didn't miss a page in your notes. There was no example 5. All right, the last piece, it's quick. It's called the discriminant. The discriminant is actually part of the quadratic equation, and it tells you how many solutions your quadratic equation will have, okay? So if you just take b squared minus 4ac, if that number is greater than 0, there are 2 real solutions, right? If that number is equal to 0, the equation has 1 real solution. And if if that value is less than 0, the equation has 2 solutions, but they are complex solutions because that means that you had a negative under the radical. Okay? So without solving, just determine the character of the solutions or determine how many solutions this quadratic equation has. Okay? Number 1, 2x squared minus 4x plus 1. A is 2, B is negative 4, C is 1, right? The discriminant is b squared minus 4ac. So let's just plug those in. D is negative 4 squared minus 4 times 2 times 1. D is 16 minus 8, or D is 8. Since that is a positive, it's greater than 0. Two solutions. 2 real solutions. Real solutions are on the number line. 2 solutions on the number line. All right, This one, A is 1, B is -2, C is 6. B squared minus 4AC. -2 squared minus 4 times 1 times 6, right? 4 minus 4 times 6 is 24, right? Two complex solutions. Or two imaginary solutions. Last one, A is 4, B is 12, C is 9. Whoa, I must have been doing this last mere moments ago. 12 squared minus 4 times 4 times 9. 12 squared minus 4 times 4 times 9 is 0. So it must be 144 minus 144. One real solution. All right. So those are imaginary numbers. They sound very bad, but I hope you think they weren't. Anyway, thank you guys. See you soon.